This is a targets Cupid and relationship question. What we've got to recognise is all the pieces of information and what they stand for. Now, we're trying to find L here, being 5x plus 720 on x, and L is the total length of y required. Now, if I'm looking for L, of course, I want to actually build this up. If that's x, I'm just going to create myself a new variable called y. And I can see that x plus x, 1, 2, 3, 4, 5x, so L is going to equal 5x plus y, which is what I would consider to be my target formula, because I'm trying to find the L formula, but it's not my bullseye because I actually need it all in terms of x. So in order to work out just in terms of x, I need to find a relationship between x and y. What I do know is that the area is going to equal 720, but the area, according to my diagram here, is going to equal xy. So 720 equals xy, and y is the one I want to get rid of, so I'll divide by x. Y is equal to 720 on x. That's my relationship. Now, whenever I want to get a bullseye, I shoot my relationship into my target, basically sub it in here, so 5x plus 720 on x, and that's exactly what they said it was going to be. To find the minimal length of y required, this is a maximum minimum question, so straight to differentiation, applications of calculus. So all I really need to do is minimize this function. Minimum when L dash equals 0, derivative's got to be 0 for a flat spot, and L double dash is positive to create that smile. So L dash would equal, actually before I do that I'm just going to say, well that's L is equal to 5x plus 720 x to the minus 1, because it's easier to differentiate. L dash would be 5 minus 720 x to the minus 2. So 0 equals 5 minus 720 on x squared, because I'd rather that down the bottom. Move it over, 720 on x squared equals 5, times the x squared up, divide the 5 down, x squared equals 720 on 5, which equals 144. If x squared equals 144, x equals plus or minus 12, because that's the square root of 144, excuse me, which equals 12 because it's length, no negatives. And we've just got to do a double check, which of course you would use more paper and scroll it along in your book. So I need L double dash, which is going to equal positive 2 by 720 x to the minus 3. And L double dash at 12 would equal 2 by 720 on 12 cubed, which is greater than 0. Therefore, min at x equals 12. We've defined that it's definitely a min. We've got to verify, and we have to actually find the minimum length. It's always good to check whether you need just where the minimum length is, or what the minimum length is. That just means sub it back in to the formula. So the length at 12 is going to be 5 by 12 plus 720 on 12. Calculator work, 120 units, meters. Done.